All right, so we are on. We are moving right along. Unit 4, day 5 notes. These are your objectives. I always like to show that at the beginning of the video. Looks like um, so many, and a lot of these, like I said, are one problem has multiple objectives. So let's start here. I would like to say that this is a very abstract um, day, I guess, of notes. Um, just understand it's pretty abstract, and just bear with me. Take your time and really practice. And Alex, it will help you if you practice and you start to see these problems. A lot of people struggle with this only because it's very abstract, not because it's difficult. Okay. All right. So we have been going along in our days before, so we're leading up to this. Um, these are the same type of problems we've been working with. So 2y minus 1 plus 4y equals 3, and then y minus 1 plus 7. Let's solve this and see what happens here. Okay, first and foremost, distribute. And we're going to distribute on this side as well. So 2 times y is 2y. 2 times -1, -2. Plus 4y, I'm just bringing that down. All right, 3y. 3 times -1 is -3. I'm just bringing that down, okay? I'm going to combine like terms when they're on the same exact side. So 2y plus 4y becomes 6y. They're on the same side of the equal sign, so I can combine them. And then I'm just going to bring that -2 down. Same thing on this side. I can combine the -3 and 7. So 3y and -3 and 7 become +4. Okay, I'm going to get the y's on the same side first. -3y. Now I'm going to do something that I haven't done yet, but I usually do once I've done this many a time. I'm going to get rid of this number too on the same line. Okay, so basically what that does is brings that number here and the numbers, the y's together. All right, I think you guys are ready for that. So 6y minus 3y becomes 3y. And 4 plus 2 is 6. So now we can get the y by itself. So y is equal to 6 divided by 3, which is 2. So that's our answer. How would you put that in Alex? You would put y equals 2 there. That's actually an equal sign, believe it or not. Okay. And so basically you like kind of pick this one as your answer choice, and this is going to be y equals 2. All right. Well, because that's what we got there. Let's try this one. Let's go ahead and try the next one. All right, I'm pulling a line. All right, so the problem is kind of like 3x plus 2 plus x equals 4 parentheses x minus 1 plus 10. And again, like I said, it isn't easy, but we can do it. All right, so we're just following our rules, distributing. This becomes 3x plus 6, and then bring down that plus x. Same thing here, 4x minus 4, because I'm multiplying 4 times x, and 4 times -1, -4. And then, not that, just the 10, just bring it straight down, okay? Combine like terms if you can. 3x and 1x become 4x. Positive 6, I just brought it down. I can combine these two. 4x, and this becomes -4 plus 10. That is +6, okay? Now, if I do what I showed you earlier, I'm going to bring this one to here because remember they're on 2 different sides, so I have to do that. I can also do the 6, the -6 on the same line, okay? 4x minus 4x actually cancels out, and then there's nothing going on over here, 0. Equals, and as you see, both of these cancel out. That becomes 0. Does 0 equal 0? Yes. If the answer canceled out and it became 3 equals 3, yes, that is true. 9 equals 9, the answer is true. When the answer is true, all real numbers is the answer. Okay? If I happen to get 10 over here, if I got 10 equals 0, 10 does not equal 0. That is not true. So that's when you get the no solution. Okay? The no solution happens when it's not true. All real numbers happens when it is true, but the variables cancel out. Okay, there is no, the x's are gone. The x is gone in this case, but the numbers that came out became true. So that's why I got all real numbers as opposed to no solution. Okay. Good. All right, so let's move here. This is where the abstract concepts start coming in. Just remember what happens when you solve for m. What it's asking you to do is get m by itself on one side. Remember that, because this is where it gets weird. Okay, so I'm trying to get m by itself. Get rid of 10. Once 10 is gone, I've accomplished what I need to accomplish. Okay, so now m is by itself. That is what I wanted. When you solve for m, you get m by itself. These two numbers are unlike. You can't just put them together. So this is just going to be n plus 10. That is your answer. Yes, it looks weird, but when the m is by itself, you solve for m. You got m by itself. That's exactly what you want to do. Okay? It's not going to be your traditional like m equals 4. In this case, m equals n plus 10. That's what they wanted. You don't have enough information to change that. Okay? So, all right. We're getting y by itself. Let's get rid of x. Subtract x from both sides. Okay? So the x goes away. It becomes a minus x equals y plus z. And again, what do we do? What do we want? We want y by itself. I'm getting rid of z now. Subtract z. So this becomes a minus x minus z equals, now y is by itself. When y is alone, you are done. You don't have to do anything else. Okay? You have to leave this ugly thing looking ugly because there's nothing you can do. Once y is by itself, you've done what you're supposed to do. Solve for y. All right? Let's go here. We're trying to get s by itself. So let's get rid of q first. I'm going to subtract q because it's positive. I'm subtracting it. So negative r plus s equals p minus q. Okay, I can't put them together. I have to put them beside each other. I'm getting s by itself. I have to add r. So this becomes s equals p minus q plus r. Again, once you get s by itself, you are done. Okay, because it says solve for s. And yes, it looks strange. I know. Very abstract. All right, so now we're getting a by itself. How do we get rid of 7? In order to get rid of 7, because it's divided, we have to multiply it. Okay? So now the a is by itself, and this becomes 7w. A number next to a letter means they're multiplied by each other. 7 and w are multiplied. But up here, we were adding and subtracting, so that's why we have p minus q plus r. This case, we're multiplying. 7 and w next to each other means they're multiplied. So that's going to be our answer, because we got a by itself. Okay? Again, I don't expect it to be super, super easy, but it's just abstract. All right, so in this particular situation, we want e by itself. Almost the same concept of what we did, but now we have m and g at the bottom. We're going to get rid of m and g by multiplying them. Okay? So that e is by itself. This becomes e equals, and then it's going to be m, g, and h. When letters are all next to each other, standing next to each other, that means they're multiplied by each other. Okay? So now that e is by itself, I'm done. M, G, and H are all next to each other. That means they're multiplied by each other, and that's what we did. We multiplied M, G on both sides. Those will be M, G, and then H. All right? Let's look over here. We're solving for G, and this is like very common. You'll see that. G is in the middle, but G is all like 10, G, and H. They're all standing next to each other. They're multiplied by each other. So to get rid of them, I have to divide them away. What I don't want. I want G by itself. So I'm going to go get rid of the 10 and the H. 10 and H. Because I want G by itself. which that's what I did. And this becomes E over 10H. That is all you can do. Practice makes perfect on these guys. All right, so now here I'm solving for S. I'm getting S by itself. Let me get rid of this whole situation first. 21R, I'm adding it. Okay, so this becomes 14S equals, it looks like 21R positive minus 7, or negative 7 plus 21R. Either way, it's fine. In order to get rid of the 14, I have to divide it. Okay? So this now becomes S equals, and on your Alex, you are going to have this situation. Okay? Yes, you have 21R minus 7 and then over 14. Now, if all three of these numbers can be divided by a number, you can simplify. Okay? But they all three have to be divisible. So if the 7 and the 14 were the only ones that were divisible, you couldn't do anything. But if all three of them are divisible, and if you can see, you can divide this by 7, this by 7, and this by 7. So you have to be able to do that to simplify. That will become what? 3R. 21 divided by 7 is 3, so 3R. 7 divided by 7 minus 1 over 14 divided by 7 is 2. So I just simplified that because they all three were divisible. If they were not, I would leave it alone. But I have to. Now, Alex, they're going to expect you to know how to do that. All right, so here, they want X by itself, okay? There's multiple ways to do this, but in these type of problems, when they have multiple unknowns, like an X and a Z, I wouldn't, for this particular one, I probably would not distribute. I wouldn't distribute, but I would, if you're trying to get X by itself, divide by 8 first. Instead of multiplying, which is what you're doing when you're distributing, divide it away so it goes away, okay? So now you have X plus 6 equals, I want to say that's Z, this is Z, over 8, okay? And then subtract 6 from both sides. So this becomes X equals Z over 8 minus 6. Again, practice makes perfect. Hopefully this does something for Alex and help you with this, with something there, because I'm sure there are some Alex situations that have that going on. All right, last page, and here we're solving for Z. Again, I would not distribute, especially if one of these are what you're solving for. I would not distribute. I'd multiply by, how do you get rid of a fraction? Multiply by the reciprocal to get rid of it. So 5 over 3, but then you have to multiply by 5 over 3 on this side. So this becomes 5 over 3x. These cancel out. Okay? That's how you get rid of the fraction. Equals to y minus z. And we want z by itself. This y is positive. I'm going to subtract it. So now you actually have negative z equals 5 over 3x minus y. I'm just putting them beside each other. But I want z by itself without the minus. So what I would do is, what they're going to probably ask you to do now, I'm going to multiply both sides by -1, but I would just change the sign of that z. If you change that negative z to positive, okay, that's what you need it to be, change the sign of everything over here. Now this becomes -5 over 3x, and that becomes plus y. And I have to do that only when that z is negative. Your answer can't be negative z. So I made it positive and changed the sign of everything over here, okay? Now, it wants you, for these two, to just translate the phrase into an algebraic expression. It does not want an equation. It just wants you to write it out as an algebraic expression. So for the quotient is division of b and 3. You're going to say b divided by 3 or b over 3, okay? Or you can just say b divided by 3, like that. Twice c 2C. Okay? Twice C is going to be 2C. Let's look at this one. Bill had N dollars to begin with. He just spent $45. Using N, write the expression for the number of dollars he has left. So he began with N dollars. He spent $45. That's the expression. Okay? So that, they don't want, they just want what they want. So they said, write an expression for the number of dollars he has left. So he has N minus 45. He spent the $45, and then whatever answer will come out of that. But we don't know the answer, so they're not asking for the answer. They just want you to write the expression. Same thing, write the expression. Joe has K decks of cards. Each deck has 52 cards in it. Using K, write the expression for the total number of cards Joe has. So he has K cards, and there are 52 cards in each. So if you do 52K or K times 52, that'll give you the total number of cards. Or you can also do 52K. It can go like that. Okay? So if you do K times 52, that'll still give you the same answer, or 52K. That is also fine. That is going to be the algebraic expression for that. Got it? All right, so that is day 5, unit 4, day 5 notes, and we are done with that.